Hello everyone, ECE350 again. Welcome back to lecture 6. Before I will start lecture 6, let me clarify this over here. So we did in the lecture 5. So here, the reflection coefficient has two components. It has its magnitude and also has the angle, right? So magnitude is basically saying how much is reflecting from the incident wave. So magnitude is basically giving you um, here how much you reflecting uh, with respect to your incident wave, right? And what is this? That are is saying that how much phase shift happening between your incident and reflected wave. So how much phase shift happening between these two waves? That R can range from positive pi, which is 180, to negative pi, which is negative 180. So it's the range for your reflected angle. All right. So now we're going to talk about standing waves and waves impedance. What is the standing waves? So when you have your incident wave going this way here and reflecting coming back here, so in the transmission line they meet each other, right? So they can meet each other to add to each other, or they can subtract from each other. If they're in phase, they're gonna add to each other. If they're out of phase, they're gonna subtract from each other, right? So now, based on that, there's reflecting wave have maximum, minimum, and it's also like a sinusoidal wave, but it has the twice the frequency of your reflected or incident wave. So because adding two of them together, right? So this is the way equation for current and voltage. To find the current magnitude, sorry, voltage magnitude for this over here. So you can find the magnitude by using the magnitude equation over here. Voltage n is complex conjugate, and square root of it will give you the magnitude. So this is the magnitude of the reflected wave, and here is your equations, right? Based on this over here, you could be a maximum or could be minimum. If this value is becomes 1, cosine can be 1, it will be maximum, or that will give you max value. If it becomes negative 1, will give you mean value, right? So you can see the min and max value based on this cosine value, right? And same with the current. So now over here, this is the voltage magnitude for in the transmission line at any point, and the current magnitude at any point. If you see the distinction over here, this is negative, this is positive, so they're opposite. When voltage is maximum, current is minimum, and so on. So how do you find where the maximum, where the minimum? Again, I said that repetition of regular wave is lambda, which is incident and reflected wave, but your standing wave has the half of the lambda, which is meant is twice the frequency, right? So this is the voltage reflected, sorry, standing wave. This is the voltage standing wave. This is the current standing wave. So how do you find that where they're gonna, where the distance for maximum voltage standing wave, what is the minimum voltage standing wave? And same with the current. If you look at here, when voltage is maximum, current is minimum, and what is voltage is minimum, current is maximum because of the sign I showed you in the beginning, right? So again, let me be clear here. If this is 1, this is 1 here, that your equation have the highest magnitude of the standing wave voltage, that is that one here. And again, if this is 1 here right now, then you'll get the minimum value of the current because it's a negative sign over here. And this is negative 1, you get the negative minimum value of the voltage, and you get the maximum value of the current because negative will make a positive here, okay? All right. So that's what I'm trying to show you over here. And again, I'm saying that your standing wave has the half of the repetition time. So that means lambda by 2 is 280. Sorry, 2 pi 360, and lambda by 4 will give you 180, right? So now let's see again, if there's no reflection, if you perfectly match line, no reflection, no standing wave, so there is no variation of voltage in the line, have the same like voltage at every point of the line. So now examine one when you have phase angle shifting by plus minus 180 degree, and your reflection coefficient 1, the 100% reflecting back. So what this means, plus minus 180. So your reflection wave and incident wave has 180 degree phase shift. So if you look at here, This is the reflected wave right here. This is the reflected wave right here. Okay. Then your incident wave is I would like draw over here. This is the incident wave here. So look at that. This is from here to here. You have a lambda by 4 distance between two peak, right? Incident wave peak and reflected wave peak. That lambda by 4, if you remember that, that is 180 degrees. So that means you have a phase shift between incident reflective wave is 180 degree, you have a short circuited load, right? Now you have an open circuited load, you know that is also reflection coefficient is 1, that means 100% reflecting back, but your phase shift only 0, that means there is no phase shift between incident wave and reflected wave. That's, you can see that I try to draw incident wave in on top of the reflected wave, so then there's no phase shift between them, right? So that's, if you also see that this wave over here, they're what do you call it? Their phase shift you can see from your equations. All right. So now we're gonna do this in the class. All right. I'm gonna leave it to you to do in the class. So now let's see how could you know that where is the maximum value, where is the minimum value? Again, from the equations of this one here, we saw that if this becomes 1 for voltage, and there's the maximum voltage, right? So that means if this one becomes 1 when it is 1 means 1 is 0 or multiple of 2 pi, right? So n equal to 0, it becomes 0. That's also 1 because cosine 0 is 1, and its multiple of 2 pi also give you 1, right? So now with that, if I try to find Dmax over here, so that's the equation for Dmax, right? And also your beta is 2 pi by lambda. You can put it back here. So that will give you this equation over here. So now talk about this. How do you do that? This is the Dmax equation. But think about that. If your theta r is negative, if reflection coefficient angle is negative, that means at n equal to 0, that will give you negative Dmax. What does it mean? That means you're having a max somewhere here, right? Beyond your physical load distance, right? That means that it doesn't make any sense. So that's why we don't need that point, because that is not in our transmission line, it's somewhere else. So we don't need that. So when theta r is negative, so we have to start from n equal to 1. Right? If we start from n equal to 0, we got a Dmax is not in the transmission line, is beyond the transmission line. It doesn't make any sense. That's why when theta r is negative, we start from n equal to 1 to n3 and 4 and so on. N equal to 1 will give you the first one, n equal to 2 will give you the second one, Dmax, because the first Dmax here, second Dmax here, third Dmax here. So we're going to go the different Dmax for different n values. If theta r is positive or 0, then we can start from 0, right? So we're going to get something very close to the load end, and you go from there, right? So that's why is a 2 distinction over here, all right? Now, for the current, as I said, when voltage is max, current is minimum, right? So if you want to know, let's go back here. If you want to know the minimum point, so this is the max point, the minimum distance over here. So minimum distance and maximum distance, there's a difference between them is lambda by 4. So minimum distance, maximum distance, there's a distance between them by lambda by 4. So if you add lambda by 4 to max, Dmax will get Dmin, right? But there's also needs to be careful here. So let's say your Dmax happens right here, which is Dmax is right here, which is less than Dmax is less than lambda by 4. That means for Dmin, you have to add lambda by 4 to get the next Dmin. So from here to here is lambda by 4, right? So you have to add lambda by 4 to get the Dmin. So that's what here. So if your Dmax is less than lambda by 4, you add lambda by 4 to the Dmax to get the Dmin. If your Dmin happens at lambda by 4 or higher, so that means your Dmin is right here. This is the lambda by 4 distance over here from here to here, but your Dmax is right here. So now to get the first Dmin is right here, so you have to subtract lambda by 4, right? That's what it's saying. So based on what is the Dmax distance from the load end, you have to either subtract or add lambda by 4 to Dmax to find the Dmin. All right. All right, that's all for this part of the video. We're gonna talk about a few other things in the next video. All right, so let's watch for the next.